All right, today we're going to do some more equation solving with trig. Some where you have to factor some more, some where we're going to solve by graphing and get decimal answers. Somewhere we're going to do some kind of crazy U substitution stuff. Okay. So we're going to start with a really simple one from yesterday. Tell me how to do this. How to solve this for all values of x. Factor out a cosine. It will say what? Okay. Then if we set each of those equal to 0, we'll have the cosine equals 0 or the sine equals 3. And where's the sine 3? Never. Reagan, this is for you before I forget. Where is the cosine 0? Pi over 2 and 3 pi over 2. Now it says all solutions. So do we have to add stuff or we don't have to add stuff? We do have to add stuff. It has a cosine has a period of 2 pi, so we can put plus or minus 2 pi n. Yes, there's other ways to write that. Does anybody want to ask if their way of thinking is right? Yes. Yes. Say that again. Yes. This would work, or you can put the plus or minus. Yep. Yep, because they're straight across from each other. Or you could put this and leave it plus or minus 2 pi n. Okay. But this is fine. I just want to make sure whoever wants to shorten it can, but that you're not confused. Are we good? All right. We did a couple of these yesterday. Does anybody remember what we had to do when there was 2 different functions in there? After we finished crying? We substituted to try to get down to 1. Now, there isn't a substitute for plain old sine other than like a 1 over cosecant, which isn't going to get us anywhere. But is there a substitution for a cosine squared that would just have a sine or sine squared in it? Sine squared plus cosine squared equals 1. So cosine squared would be what? 1 minus sine squared? Yes? If I move this over here? Okay. And then the rest of this said plus a sine plus a 1. Then what happens? Can I take out a sine? Well, I have a 1 and a 1, right? That's 2. And I have a plus sine x and a minus sine squared of x. We could factor it. We could move it all to the other side, multiply it all by -1 and factor it, whatever makes you feel more comfortable with it. If I just, what are the factors of 2? 2 and 1. What do I need back here? Sine and sine. Now, right now I have 1 sine and 2 sine x. What will give me a positive 1 in the middle? If it's a positive 2 and a negative 1. Okay. How many of you would feel better if we had rewritten that as sine squared minus sine x minus 2 equals 0? In other words, changed all the signs, put the sine guy in front. I need that one. It's exactly the same thing. I promise. Okay. Have this? No. No, this is notes, right? The top of, okay. Which one? Over here? No, because when we changed all the sign, this would be a negative. So we'd get over here, sine x equals 2, and sine x equals -1. Over here, we'd get sine x equals -1, and here, 2 minus sine equals 0 means 2 equals sine. Okay, get the same thing. All right, so this is the same problem, just done a little differently, but what's the bottom line? Can sine ever be 2? Sine is -1 where? 3 pi over 2, and that's the only spot, right? So it would repeat every 2 pi. Hi. Okay. A bunch of stuff from guidance for a bunch of you. All right. We good? All right. This one says solve only on the interval 0 to 2 pi. And then it says graph to check, which kind of makes me wonder if something maybe isn't going to check. But what do I need to trade here? It's just like the last one. There's one that says what? Tangent 1 plus tangent squared equals secant squared. So how could we trade for a tangent squared? Secant squared minus 1 equals tangent squared. And then it says plus secant and a -1 back here. So this was our trade. How does that simplify? Secant squared plus secant. Okay. I feel like we haven't done one with a secant before. Okay. We can handle this. Secant, sorry. I'm thinking ahead here. Secant of x and secant of x, 2 and 1, right? We need a plus 1 in the middle, so we need plus 2 and -1. Okay, so what do I get? The secant of x could equal 1, or the secant of x could equal -2. Anyone have any ideas? Where is it true that the secant is 1? When cosine is also 1, right? If I write this as 1 over cosine, and I just kind of cross multiply, I get the cosine is 1, right? So then we need to answer where that's true. This guy, if I write this as 1 over cosine, cross multiply and divide, or just flip both sides over, right? Same thing. So I get cosine equals what? Everybody okay? I don't know what's going on. Are we good with this or not? Oh, okay. We gonna be all right? All right. So the cosine is 1, happens only at 0 in every 2 pi after that, which is also 2 pi in every 2 pi after that. Are we good? And the cosine is -1/2, happens where? Oh, does it say that somewhere? Okay there. Thank you. Yep. Do we include 2 pi then? Why not? Okay, it says the parenthesis means don't include 2 pi, right? We're supposed to include 0, which is what we will write, but not include 2 pi. All right, so I'm liking this question better already. We only need to know where this is true and what 2 places is this true. All right. So then what I did was I typed in the calculator. How would I type that all in, guys? Can you tell me what I should have typed in? How do I do tangent squared? Tangent, close the x squared, plus, how do I do secant? 1 divided by cosine of x. You actually don't need those extra parentheses, but I put them just because I wanted to make sure that was working right. And then minus 1. What am I trying to figure out where it hits? Need to be in radians, guys. I want to know where it hits 0, right? So where it crosses the x-axis. If my window is set up from negative 2 pi to 2 pi, how many places is it crossing? You could set your window just 0 to 2 pi, right? But does it look like 3 solutions is correct? I think I have it on here still. Let me just turn it on so that the window is 0 to 2 pi, because that's all they ask us to look at. So if I set my X window as 0 to 2 pi, I did a zoom trig first, so that's where it picked the negative 4 to 4 for the Y. But this is what I'm seeing, and I want to know how many times it hits what? 0, right? Now, it looks like it's hitting 4 times, but remember the fourth one over here is 2 pi. We already discussed that we're not supposed to include 2 pi. All right, so I'm happy that it seems like there should be 3 answers, and I found 3 answers. How could I check that my 3 answers are right? How would I know that 2 pi over 3 works? Go to trace 2 pi divided by, yikes, what did I do? 2 pi divided by 3, enter, and it should jump right to that solution right there. And it comes up exactly 0. Any questions about checking your answer by graphing? All right. This one kind of gives me the heebie-jeebies. Does anybody remember what we did yesterday? At the very end, we talked about one like this. There's no good way to trade a sine for a cosine. We had to square both sides, yes. Okay. Remember also that squaring both sides can cause extraneous solutions, okay? All right, so over here I have 1 plus cosine times 1 plus cosine, which gives me what? Okay, I wrote that in a very random order, but I think I got everything that you said there. Okay, on this side, I have square root of 3 times the sine of x times another square root of 3 sine of x, but whoops, square root of sine. Just kidding. Remember, we're not foiling this time, though. This is all just straight up multiplication. So square root of 3 times square root of 3 is 3, and sine times sine is sine squared. Okay, now what? We can trade a sine squared out for a what? One minus cosine squared, right? Because it's sine squared plus cosine squared equals 1. So if we isolate sine squared, we got to move that guy over there. All right, can I not rewrite this until I've distributed? Remember there was a 3 here, right? So what's that going to look like? Okay, now I need to get everything equal to 0, I'm thinking, yes? What happens? If I add 3 cosine squareds over here, I get... I'm adding them, right? 4 cosine squareds. And I already had a plus 2 cosine of x. And then I subtract this 3, I get what? We can divide out a 2, you are absolutely right. So this becomes 2 cosine squared plus cosine minus 1. Whoops, no parentheses. All right, now what? All right, so we have a 2 cosine with a 1. Is there something really good going on over here, or what's all the chitter-chat? Where's the negative going to go? Which parenthesis? That one? So that this one is a plus 2 and a minus 1 to give us a positive 1 in the middle? All right. Do I need to show work, or you can just tell me that this first one would mean cosine is 1/2, and the second one would mean cosine is -1. Was this all or 0 to 2 pi? Thank goodness. Okay. Cosine is positive 1/2 at pi over 3 and 5 pi over 3 and -1 at pi. Okay. If we graph this, how would you type that in? Pretty easy, right? Can we just do it in 2 equations? I don't know what I just did. The stupid button. Can I just type in one line 1 plus sine x? And then in the other line, square root of 3 close parenthesis times sine x, right? I feel like no one's doing this with me. And then square root of 3, make sure you close the parenthesis, and then sine of x. Someone want to hit the light? Thank you. All right. 1 plus cosine and square root of 3 sine of x. Okay, if I graph, I want to know where they intersect because I put them in 2 separate lines, right? Y1 and Y2 or whatever I did. How many solutions are we looking at here? 2. And if this is 0 to 2 pi, does it look like one of them is pi right here in the middle? And it looks like the other one must be which of our answers? Pi over 3? Because 5 pi over 3 would be over here somewhere, right? And they're not looking good. All right, let's check 5 pi over 3, guys. If I put 5 pi over 3 back in here, please stick with me. What is the cosine at 5 pi over 3? So this side would say 1 plus 1/2 equals, what is the sine at 5 pi over 3? So this side would say this, okay? Well, on the left, 1 plus 1/2 is 3/2 or 1.5. Square root of 3 times square root of 3 is 3/2, but what happens? It's negative. That's why it doesn't work, okay? Remember when we squared it though, if we squared both of those, they would be equal, right? So we got an extra solution. All right, those are tricky. I don't think I would put that one on a quiz, just too much work. All right, we're going to be graphing. Everybody got their calculator? Because we're just going to solve this one by graphing because this is ugly. Now, I will tell you, let's just solve it by graphing before you get all bent out of shape, and then I'll show you how I would have had to do this back in the day. Back in the day. So what are you going to do? Any ideas? Yep, just graph a plain old sine x in one of your equations. Just kidding. I don't even know what I'm doing. I just can't see these stupid keys on this thing. Blind. Okay. So I'm graphing sine x, and it says 0 to 2 pi, so I made my window 0 to 2 pi, and I get this. What else do I maybe need to graph, though? Yeah, negative 0.729. Okay. I could change my window, the Y, and stretch it up and down a little better so I could see better, but it really doesn't matter. It's crossing twice, I think, yes? So I'm supposed to find those intersection points. I got one is at 3.958 if we go 3 places. Oh, we're supposed to go 4 decimal places in the directions it says, right? 9585, maybe? Okay. And if I find the other intersection point, anybody get that one? Whoops, I got carried away there. All right. And that's all you're supposed to get for this. We're done with this question, except I want you to see what we used to have to do before we could just graph it. Can you just put down your pencils and watch the fun with Hofbauer for a second? Okay. So when you saw this question back, even you would have done second sine of negative 0.729. Does that seem okay? Okay. Why does it give me a negative answer? Okay. Even I, before a graphing calculator, had to know what a sine curve looked like, right? Okay. When you push second sine, it found the nearest place to the origin that was true, which was at negative 0.8 radians, okay? Roughly. What I had to do was try to find these two answers over here based on symmetry. This little distance is how long right in here? 0.8, right? So how would I have found this answer right here? Pi is right there, yes. Plus how much further? So I would have done pi plus 0.8168, and I would have got this answer right here, guys. How did I get this answer over here? This was 2 pi, and I said I have to go back exactly 0.8 whatever, and I would get those two answers, okay? So I had to use symmetry. All right. This says all solutions. Do I have to do anything different? I need to find two of the solutions and then do what? Why am I putting 2 pi in? because it is a sine graph, right? If it had been a tangent, I would have just put plus or minus pi. All right, are we okay so far? All right, now for fun, we're gonna do a really crazy one. You'll like this one. Okay, type this craziness in. 2 cosine. Guys, please do this. 2 cosine 3x, close parenthesis, minus 3 sine 4x, close parenthesis. And then you're supposed to see where it hits 3, right? Okay, I'm going to leave my window 0 to 2 pi. It's kind of cool, huh? Okay, we're supposed to find the answers. How many answers are there between 0 and 2 pi? 4? Okay. How about, ladies, you find the first 2, gents, you find the second 2. The last 2 on that. My calculator can't even find any of them. I think I got to get closer to the actual spot it intersects. All right, eventually I found one at 0.61916. Does someone else have another one for me? Okay, it says like 4 decimals. 795. All right, good enough. Okay. 4 point more places. It says 4 to the nearest 0.001. Okay, but there's 2 of them up there, right? Did she find a different one than you did? Okay, 4.0315. Check if you typed it right, because it is a really crazy equation. You might have put a 2 or a 3 in the wrong spot. $4.53284. That's a 5 and a 3. Okay, it's a mess. All right. Tangent. All solutions. Okay, my window isn't going to work right now. Does anybody know why my window isn't going to work? Actually, that would be okay. Does anybody, it went out to 2 pi and I don't really need it to go out to 2 pi. What is the other issue though, guys? Tangent of x. I want to know where it hits 6. Doesn't show it in the picture because my window doesn't go up to 6 right now. I have to change my Y window to go up to like 7. Now, depending on how you have this set up, it might not look like it hits 6. Because depending on the window you set, sometimes this will go so steep that it'll stop. But it does hit 6. Do I need more than one solution? Okay. But it's a tangent, so I could just find the first one, right? and then add pi, because it should be repeating every pi. 1.4056 plus or minus pi n. All right. So solving by graphing. Easy peasy? Okay. Now, I need your eyes back up here because this is probably the hardest thing we're doing today. We are going to do what's called a U substitution. We are going to find the sign is negative square root of 3 over 2. And then we're going to worry about this. Okay. Where is the sign negative square root of 3 over 2? Four pi over 3 and 5 pi over 3. Okay. What does this 2 in here do? If I were to graph the sine of 2x, it changes the period to what? Pi. So is it going to happen more often or less often? Here's pi now. 2 pi, right? So if I want to know where it's hitting this, between 0 and 2 pi, I'm going to hit how many answers? 4. All right, so this is what I'm going to do. I'm going to write this as though it were an infinitely many solutions answer. Because it is now, what was u? 2x. Okay? This was really a 2x. So what are we going to have to do? Yeah, multiply by half or divide by 2, right? So I will get x equals, if I do a half over here and a half over here, what is this half going to become? It would be 4 pi over 6 or 2/3. But it would also say back here plus or minus, yes, we have to take half of that, so pi n. Now they don't want all solutions, okay? What you just actually found is the answer to this question over here. What we want to do is we want to find all the solutions that fall before 2 pi. Well, 2 pi over 3 is one of them. But what happens when you add 1 pi to that? 2 pi over 3 plus pi. Now, if I add another pi, I'm going to be past 2 pi, right? And it's set up here to stop at 2 pi. Okay, so I need those two solutions. Back down to this question. 5 pi over 3 plus or minus 2 pi n was where this hit negative square root of 3 over 2. But there was a 2 in here, so we need to divide all of this by 2 or take half. What will that say if we take half of it all? Okay. So that's actually the other answer to this. Because this is the exact same question over here, but it says all solutions. Okay. If we want to find only the solutions between 0 and 2 pi, we say those two plus 5 pi over 6 plus, can we add pi? What is 5, 6 plus 1? Look up here, guys. 5 pi over 2, 2/3. No, 5, 6, 2/3, 5/3, and 11, 6. Are those the 4 answers, maybe? Okay. Because if I kept adding another pi, right, I'd go past 2 pi. All right. These U substitutions are tricky. I know that. So we're going to do some right off the back where, oh. You have a couple bookwork problems like this. Do you really need me to do this, guys? You put this in Y1, you put this disaster in Y2, and you find where they intersect between 0 and 2 pi and give me decimals. Can you do that without my help? Okay. I would rather go to 4B. Let's look at this lovely question here. This just look fun? Honestly, this is about them being silly and trying to make this look harder than it is. What are you going to do first? Divide both sides by -8, and then it will say the cosine of 2 theta equals what? Negative. This goes in here twice, square root of 2 over 2. All right, you didn't trick us. We figured it out. That wasn't that hard, right? But now the trick is we got this 2 in here. So we're going to pretend for a minute that this is just u. So we're going to say, where is the cosine? Negative square root of 2 over 2. And I want to pretend it says all solutions. So cosine negative square root of 2 over 2 happens where? Okay, and? All right, but that's what u is equal to, right? And u, we decided, was really 2 theta in this question. So what are we going to have to do to our answers? Divide by 2, or take half. When I take half of all that, I will get, what's half times 3 pi over 4? 3 pi over 8. Wow, I didn't know I could find that solution. Plus or minus, when we take half of this, we'll have pi n. Okay, I'll come back to finish that in a second. Take half of all of this. We'll have theta equals, what's half of 5/4? And half of 2 pi n is, okay. Now I need to find the actual solutions without n's. So the first one is 3/8. The next one I would add pi to. What would 1 plus 3/8 be? 11/8. Type it on your calculator. Okay. If I add another pi, is it going to work? Does everyone understand that 11/8 is still less than 2, right? Okay. Then I had down here, what? 5/8. We could have put that in this different order, but it doesn't matter. If I add 1 to 5/8, I get, is that less than 2? Okay. What? Okay. Number 2. What does number 2 say? I didn't put it up. Okay, number 2 says 0 equals what? Well, this matters not at all. If you divide both sides by -1/4, you still have this. So then where is the cosine? 0? And pretend you're solving for all solutions, and then divide everything by 2. You'd be okay? I wanted to do 3 because 3 looks totally horrifying, right? Okay. Any ideas? Divide by 1? I don't think that'll do anything. What do you think? Can anybody think what we could do over here? It's 3/3 plus square root of 3 over 3, right? It's like if you had 1 plus 2 all over 7, it's 1/7 plus 2/7, right? It's the same thing. So we're just separating it. Now it's looking a little bit better because what? This is 1, and I can subtract 1 off each side, yes? So I'm down to the tangent of 2 theta is square root of 3 over 3. Okay. I'm going to pretend that just says u for a minute. And u would have to be, where is the tangent? Positive square root of 3 over 3. Be careful. It means we're looking for an ordered pair with this. Right? Because you put that over that, and you'd get square root of 3 over 3. That's not right. Someone yell at me. You'd have 1 in square root of 3, right? To get square root of 3 over 3, which is pi over 6. Am I right? Okay. All right, and how often does that repeat? Tangent has a period of? Okay. So now u is really what, though? 2 theta. So what do we have to do to all this? Divide it by 2, so we get theta equals half of pi over 6 is pi over 12, plus or minus half of pi n would be pi over 2n. Okay. Okay, I need a calculator. Got a calculator? I'm going to write down 1/12 and put 1/12 in my calculator, and I'm going to add what to it? One 1/12, and I'm supposed to add 1/2. What's that? 7/12? Okay. Then I'm supposed to add 1/2 again if it's not too big. Is that 13/12? Is that over 2 yet? Nope, we got to add 1/2 again. Did the directions say to 2 pi for this? Right? We have to keep going till 2 pi. 19 pi over 12. Now, if I add another 1/2, I'm thinking I'm going to be too big. I get 2 point something, which is more than 2 pi. Okay. Well, wasn't that just fun? Guys, what's different about this one? This one's really icky. Well, it's not. It's actually easier. I'm doing this fast. Guys, look what happens. This goes away. I have, where's the sign? Square root of 3 over 2, which happens at pi over 3. And it happens at 2 pi over 3. Guys, please pay attention for 1 second here. But this is not, this is u, which is not 2. It's what? It says that's 3 theta. Now, this seems like it'd be really hard, but look, it says all solutions. So all you got to do is take 1/3 of everything and you're done. So it's going to be theta equals pi over 9 plus or minus 2/3 pi n. And 1/3 of this would be 2/9 plus or minus 2/3. Okay, there's number 8 done. The assignment is to work on all of this fun. There's not very many questions, so get caught up. Don't forget, whatever I decide to give that retake, you have to have remediation done, right? One second, let me stop this recording.